Okay, greetings, ladies and gentlemen. This is Labs Mining, and today in engineering mathematics, we are going to continue with limits. And the question reads: evaluate 1 over x squared as the numerator over sine squared open bracket 1 over x as the angle and the denominator, and then limit as x approaches positive infinity. So before we even go to our solution or solutions, okay, make sure that you subscribe, you share, as well as liking this channel so that you keep being posted with the videos that will be uploading. Okay, so we can proceed in this way. In this case, what we're going to do is just imagine you have something like this limit as x approaching. Okay, so this positive infinity, it can also be represented by positive 0 like that, or just a 0. It is the same meaning. The next thing that you have to do is try by all means to work out on the numerator part, which is having 1 over x squared. You write it like this: x squared, you raise also that 1 to the power 2 so that it can equalize the power or the degree of x squared. And then you say over, down you have got something like this, okay, squared 1 over x. Okay, you have something like this. You can still proceed by saying limit, okay, as x approaching positive 0, just 0, then you can factorize the power there. Okay, you can say I can still write this expression in that form like that, then over sine, and then 1 over x like that. So once you do this, then you make an assumption by saying let, okay, any letter, for example y, represent 1 over x. Okay, if that is the case, then what we're trying to say is, here we'll say limit as x approaches what? Positive 0. Where there's 1 over x, you put what? Y. Now, because it is having a squared, you maintain a squared like that. Then over, down there, you are going to have sine squared, and then this 1 over x is same as what? Y. Okay, so you're going to have something like this. Now, immediately the language changes to y from x. Make sure that you also change this x, because you're not going to replace anywhere there. Where you are going to replace this 0 is no longer x, it is now y. So you have to say, therefore, my limit will be y should approach positive what? Positive 0, like that. And then you have got this, and you can notice that I can still write this in this form, in that form. Okay, it can still mean the same, or you do that, you open the bracket again, say y over sine y. Okay, it's just the same meaning, because you still have y there, sine there, so the meaning is just the same when you multiply. Okay, so in this case, you notice that we're going to have such kind of an expression. Take note that when you are multiplying two functions or dividing, this limit is distributed to each function independently. I mean, you are going to, okay, to distribute this limit specifically to this, okay, to that around, and then you can do that. You also multiply there with another limit, as you know, y approaching positive 0. I said positive 0 same as what? Just a 0. And then I'm going to have y over sine y, something like that. And then once you do this, you are going to recall something that we said in that other video, to say uh, there's a certain condition which says that, or let me just say, it's just a standard, that if you have got limit of n later, now in this case it's y. That's why I said it's not always x in the past videos. Okay, so in this case we're doing it y, as y approaches 0, and then you have got, for example, a sine of any letter, in this case it's y, over what? Not x always, but there we've got y. So if you have got something that is looking like this, then the whole root of this expression simply means what? 1. Okay, so now if you notice what we have here, we have got a y on top, and the sign y down. Even there I've got a y as the numerator and this sign y as the denominator. So in this case, here you have got now the denominator, which is a y, and the numerator, which is what? A sin y, which is the opposite of this. So which means this is what? The inverse of that one, which means this is the opposite of that one. So which means if this original expression is equivalent to 1, which means even the inverse will still remain what? 1, because the inverse of 1 is 1 over 1. Okay, so in this case, even this one will still remain what? 1. Not really this one alone, but including what? These limits. Okay, so this part you are going to have a 1. Also, if you say times, this part again you still remain what? It will still remain as 1. So then you are going to multiply a 1 times what? That 1, which will give you what? 1. So this is the final answer specifically to this question that we are told to evaluate. Thank you for following. See you in the next video.